So here we're going to use oxidation numbers to balance a reaction. So these are the step-by-step processes that we're going to do. Some things that you're going to have to note is sometimes you're going to have to do it a little differently depending on the types of questions. But these methods usually work pretty much every time. It's just those more complex that might change it a little bit. Now the first thing we need to do is number one, that's assign oxidation numbers. So you should know how to assign oxidation numbers so far. So oxygen would be -2, hydrogen's +1, this is -2, this is +2 because it has to balance out to a neutral compound, right? So +2 minus 2 equals 0. This is a neutral compound, right? NO. This is an element, so it has 0. This is +1. And then we can find what nitrogen is, okay? Because this is a neutral compound, your oxidation numbers are going to add up to 0. So we have 3 hydrogens multiplying a +1, adding x. So that makes it x equaling -3. So here, nitrogen would be -3. Now we're going to go to 2, and we're going to use the change in oxidation numbers, and we're going to find out the number of electrons transferred per atom. So as we can see here, oxygen changes oxidation numbers. Nitrogen changes oxidation numbers. So nitrogen here, it looks like it loses 5 electrons per nitrogen. Okay, so it's per a single element there. So we went from -3 to +2, so that's 5 electrons lost per nitrogen. Now, the question is, should I use this oxygen or this oxygen? I would suggest using this oxygen because you don't want to talk about it in terms of one single compound, because that can get really confusing. So here we're going to talk about it over here. So I'm going to balance using that water, okay? So here we can see that oxygen gained 2 electrons per oxygen. Okay, it's just per single O. Now, what you want to do is you want to ask yourself, okay, what is my reactants balanced as? Like here, I'm talking about a single nitrogen, so I already have a single nitrogen. My reactants oxygen is O2. So let's talk about this in terms of 2 oxygens. So this will be actually 4 electrons per O2s. Now we can start balancing this a little better. Okay, now we're going to go to step number 3. We're going to determine the number of electrons transferred per reactant. So that's what we did there. We decided, okay, this reactant has 2 oxygens, so that's the amount of electrons transferred per that oxygen. Now we're going to calculate the simplest whole number coefficients for the reactants that will balance the total number of reactants transferred. Okay, so at this point, what we're going to do is we're going to figure out how can I get the same number of electrons being transferred. Well, here, the smallest number would end up being 20. Okay, that's the lowest common multiple. So here, if I multiply this by 5, I will get 20 electrons per 5 O2s. Another way you can write this is 20 electrons per 10 oxygens, right? This is 10 oxygens, this is 10 oxygens. Now, another thing over here is for how do I get this to 20 electrons? Well, I multiply it by 4. So this will be 20 electrons per 4 nitrogens. Now I can start actually balancing this thing. So I'm going to balance based on electrons. So for 20 electrons to transfer, I need 4 nitrogens. So I'm going to write 4 and 4 here. So there's 4 nitrogens forming 4 NOs plus H2O. Now my next step here is I need to balance my oxygens based on electrons. Now something to note here is I'm going to balance based on my oxygen. So I need 10 oxygens in order to be transferring 20 electrons. So over here, I'm going to put 5. So now I have 5 oxygens there. And I'm going to put 5 oxygens here. Okay, so I have 5 oxygens. 5 times 2 is 10 oxygens. Or sorry, 10 oxygens. So at this point, I need 10 oxygens on this side. Now this is why this question's a little tricky. Here I have 4 oxygens. Here I have 5 oxygens, so that's 9 oxygens. So I'm going to add 1 more hydrogen. And I'm going to end up getting 6 H2O. And we should check if everything all balances out nicely. So 6 times 2 is 12. 4 times 3 is 12. Okay, so all of my elements are balanced out, and now I have 4 plus 6. 4 oxygens plus 6 oxygens gives me 10 oxygens, so that means I have 20 electrons transferring for those oxygens. And now I have 4 nitrogens.